Welcome to The Explainer. Today, we are pulling back the curtain on a super powerful Python feature. Seriously, this is one of those things that's absolutely essential for writing smarter, safer, and way more efficient code. It's a little trick that really separates the beginners from the pros, and it all starts with a puzzle that honestly looks like it was designed to break Python. So let's just dive right in with that puzzle. We're going to look at a little snippet of code that on the surface seems like it's guaranteed to crash. Why? Well, it involves the one mathematical sin we're all taught to avoid from day one, dividing by zero. Okay, here's the code. Simple enough, right? We set x to 0. Then, that if statement checks for two things, x and a math operation, y divided by x. Now, we all see that y is 10 and x is 0. That means we are literally telling Python to divide by 0, which should throw a big, scary zero division error and stop our program dead in its tracks. So, what do you think happens? And it doesn't crash. Not at all. It doesn't even break a sweat. Instead, our program just calmly prints out math blocked and keeps on going. The huge error we were all expecting just never happens. So how on earth is that possible? The secret here is a wonderfully efficient feature built right into Python called short circuit evaluation. You can kind of think of it as Python being lazy, but in a really, really smart way. It just doesn't want to do any more work than it absolutely has to. The second it knows for sure what the final outcome of a logical check is, it just stops. So, the key to this whole thing is understanding how this short-circuiting works for Python's two main logical operators, and OR. Because they each have a very different trigger for when they decide to just stop caring. You know, the best way I've found to think about this is with a little analogy. The AND operator, well, it's a pessimist. It is constantly looking for any reason to say no. The moment it finds a single false value, it knows the entire expression can't possibly be true, so it just gives up and stops right there. On the flip side, the OR operator is a total optimist. It just needs one little reason to say yes. The second it finds a single true value, it knows the whole thing is going to be true, and it immediately stops looking. Okay, so let's see how this idea actually builds into something you can use every single day to make your code more robust. Because this isn't just a quirky party trick, it's a fundamental safety feature. So picture this. You're working with some data, maybe from a database or an API call. You might have a variable, let's call it user_data, that could totally be none if, say, that user doesn't exist. Now, if you blindly try to access something from it, like user_data.getName, your program is going to crash hard. But this is where our little pessimist, the AND operator, comes to the rescue. By structuring our check just like this, Python first looks at user data. In our scenario, it's none, which Python considers to be false. And because the AND operator is a pessimist, it sees that first false and immediately short circuits. It just stops. And that right there is the power of short-circuiting as a safety net. The second part of our expression, the dangerous part that would have caused the crash, is never even reached. Python doesn't even bother looking at it. And so your program just continues to run smoothly, completely avoiding that error. It's brilliant. And this same logic applies to making your code faster, too. Let's say you have a really simple, quick check like isAdmin, and then a very time-consuming function, expensive check. By using the OR operator, our optimist, if isAdmin is true, Python knows the whole condition has to be true, and it completely skips running that slow, expensive function. It can save a ton of processing time. All right, so you've seen the serious, practical side. Now let's have a little bit of fun. Short-circuiting lets you do some incredibly clever and concise coding tricks that can make you look like a total Python wizard. So here's a little challenge for you. How would you write a single line of code that prints magic if a number is 42, but does nothing otherwise? And here's the catch. You are not allowed to use an if statement. It sounds kind of impossible, right? But it's not. And here is the solution. It's all about that AND operator again. See, if n is anything other than 42, that first part is false. Our pessimist AND operator sees that, short circuits immediately, and never even gets to the print function. But if n is 42, that first part is true, so Python has to continue on to the second part, which then executes the print. It's pretty cool, right? All right, you've seen the theory, you've seen the tricks. Let's put it all together with one last logic test. Okay, take a close look at this code. We've got A set to 0 and B set to 1. The condition is A or B and not A. And just remember, in Python's Boolean world, 0 is like false and 1 is like true. So what's the verdict? Is this code going to print yes, or is it going to print no? Let's break this one down. It really all comes down to the order of operations. Python evaluates not first, then and then or last. So first up is not A. Since A is 0 or false, not A becomes true. Okay, next, Python handles the and. The expression B and not A turns into 1 and true, which of course is true. So finally, we get to the or. The whole statement has now simplified down to A or true, which is 0 or true. And since our optimist or operator finds a true, the entire condition is true and, yes, gets printed. So the crucial thing to take away from all of this is that short circuit evaluation isn't just some obscure, weird feature. It is a fundamental tool that protects your code from errors, it makes it run faster, and it even allows for more elegant, clever solutions. Understanding when Python decides to stop working is really key to writing better, more Pythonic code. And now that you've really grasped the logic behind short circuiting, that knowledge is yours to keep. The only question left is, what other elegant Python shortcuts are you going to discover next?